Yeah, my beautiful people. What's up? How you guys are doing? Thank you so much for coming back. If this is your first time, why not join this family? Smash that like button and you will really be able to join the family. And also ensure you click that bell notification. So whenever I drop a great video like this, you'll definitely be notified. So today, we have before us transistors. Yeah, transistors. I have a lot of them here. I have the A9 1941, 1943. I have the C51 and 5198, 51 200, and the rest. You understand? So I have them, and also I still have this board with me, so we'll be able to test different type. Oh, let me show you now. I have C. Okay, I have two and 3904 transistors. I should be able to have. No, this is still. Let me see. Okay, I have C1815. Sorry, my camera may not be able to pick up this. Sorry, just pardon with me for now. Very soon we'll break. So this is C1815. I have 2N3904 here with me. You understand? So you're able to see all of them. We'll test them together and we'll look at it. When we talk about transistors, transistors are very, very useful electronic components. Sincerely, they are very, very useful. And now, although based on the area and the aspect of electronics where you apply them to determine the kind of function it will give there. You understand now? For example, 90% of them can really work in amplification, and all these amplifier, frequency response, and the rest. Most of them work there. And when you look at all these inverter, now when you look at inverters, like all these your sinusoidal inverter and the rest, you see where you convert your direct current to alternative current, the one that is coming from your DC source to your alternative source. You understand? Yeah. One thing that really determines the watts there is the transistor. You understand now? So it is the one that will be A that will power it up. Now, for example, if you look at this board, this is just a small board, which is, I cannot even remember the rating, maybe around 100 watt, no, like 100 watts. Let's just assume 100 watt, but not beyond that, not 1,000 watt. Now, this is a very small one. Now, if this is 100 watt pre-board, I can definitely upgrade this to a 1,000 watts board. You understand? So what I'm simply going to do is add more transistors. Mind you, is not just to plug it in with it. I will be able to use my choke, use my heatsink, my transistor. And mind you, in the process of increasing the transistor to gain more wattage, I need more power that is from my transformer. You understand? So the lot, and that is why I say you should subscribe to this channel so that you get full videos. So I will be dropping a video definitely every week, mostly likely maybe it's Monday or Tuesday because that is my free time a bit. Okay, so I'll be dropping more video on you. So whenever any video you want or any issue you want me to relate to ask for you, you can definitely drop that. All right, so for the transistor we have here, pardon, this is A. Sorry, you cannot see, my camera cannot really pick itself. But this is 2SA1943. This is A1941. This is a driver transistor. It's a driver. In a pre-board like this, it's the one you are seeing here. They are the driver, you understand? So all this one will be the one that will go to the visiting. But don't worry, when we start doing that, you'll be able to figure it out very well. So I believe you really understand the way transistors work and what when we start talking about the wattage and the rest, it's also dependent on the power. The transformer that is powering it matters a lot. So if my current board is using 30 volts and I'm adding like 8 or 10 transistors, mind you, the transistor will work, but it will not drive, it will not give the exact wattage because there is no enough power to really push it up. Okay, so let's now dive into the segment where we'll start the testing and we'll proceed further on. Remember, set your multimeter to continuity. Then there is something you should note. I have it here to save you time. Okay, you should be able to see this now. Now, for my C20, You remember I have C1928 here, I have 1941, which are driver transistors. Then I have my 2SC200, 2SC1941, and the rest. Then I have what is this so-called C2074. I have it here too. Yeah, and the rest, but that is not what we are more concerned about. But let me just explain for those of you that will be concerned about the wattage and the rest, or in amplification. Yeah, in amplification, this is the way it really works. Because sometimes when you see the mode of connection, you see that transistor here, transistor here, transistor here. Some of you will be wondering, these three legs, why is it that some are joining each other? Where you see this one will go to the fuse, this will go to the fuse too, so go to the fuse, and you see this part will come here, it will go this way, it will touch this one, it will go this way to touch this one, then this one too will go this way, it will go. You understand? You begin to wonder why. Here is why. Now look at it. For all your C200, now they are called negative, positive, negative. That is NPN. They are NPN types of transistor. You understand? Why for the A1943, they are PNP. That is, this side must be negative. This pin here must be negative. Why this side will be positive? Why this side will be negative? So if I'm putting my positive probe here under normal condition, it should not read. You understand? But if you look at PNP now, this is positive, this is negative, this is positive. So the middle should be negative. Don't worry, we'll test it out and we'll see. And another thing, in terms of amplification, these are what you should really know. This middle, the positive side coming from my power, part, you understand, will come to this. You understand? Based on the power, let's assume I'm using 50 volts to drive it. Mind you, it's not just one, they're like 4 or 5. So the positive that is coming there will come to this side. Why the negative that is coming there will go to this side? Do you understand now? So this is my output. So my out will connect with this out here. You understand now? Then everything will be sorted out. Then my in will connect with mine. So combination of all these in. So if I'm combining a transistor now, for example, let's say 4 NPN, 4 PNP, that is the in of all the NPN will connect, the in of all the PNP will connect, the out, all of them will connect to, then my positive will connect together also. Then the negative, no, the positive are not connecting together. Don't worry, I will do a detailed diagram for that in one of my video. If you like, if that is what you want, just drop it in the comment section. I'll definitely do that for you. So let's now test this. I believe you are gaining a lot of mastery in this video course. This is C. This is C. This is C now. This is A. I brought this so that we can test the good ones and also the bad ones too. So this is my multimeter. So remember, set it to continuity. Look at my screen. If it's reading, and you can hear the sound too. So remember, this is C50 C5098 is still the diverse transistor for 5200. Okay, so it is an NPN, that is middle plus. So if I put this now, so let's see, do you see now? Nothing is reading. So let's invert it now. Do you see it now? It's reading now. Well, if I put it here, see, it's not reading at all. If I do it this way, it will read. So one thing to know when it is good, I will check another one where you'll be able to compare. Don't worry, we'll compare and contrast when you see good one. So this is my negative now. And let me take this away so we can see very well. This is my negative. How to test when you are using a good one. You see it, my negative is here, my positive is here, it's reading. If I put it here, you see, negative is here, reading. If I put positive here, this here, no reading. But if I put it this way, no reading. But if I do it this way, so it must give you reading in just two directions alone, this side and this side, reading. And the value must be the same if it is still good. Now let's now change our probe to the other way around. Look at it now. You know, at first it was reading this way, but this way it must not read. If it is reading in both directions, that is to tell you there is a problem somewhere. You understand? See? So it's reading in just this direction of the emitter location. You understand now? So this transistor is still a very good one. Let's look at this one. This is A 1941. I see it reading this way, giving me 1607. If I invert it, it must not read. You see, it's not reading, so it's a good one. Let's see this way. Not reading, but if I do it this way, reading. So this is a good one too. Now let's check for a bad one. Let's see what the behavior will be like. Now, you see, you can see the sound already without even reading any everything is making noise. So we check this. A good transistor should not, because you know transistor is just combination of various diodes together. You understand now? Where you have the collector, the base, and you have the emitter. I don't want to jump pack this video too much. That is why I'm just trying to keep it simple. If you want more extensive video on that, just let me know. All right. So see it now. Making noise in this direction. So this side is bought, is not. Let's see the other way around. You see? So this direction, sun, this side again. So it's short already. But let's confirm further. 0, rubbish. So you can see this transistor is bad because it's giving reading in all direction, which ought not to be so. You can see it. 1. If I invert it, the same thing, the same thing, the same thing. You see it now. So there is problem with this transistor. It's really bad. So let's check for this one. So let's see. You see it now. Oh, sorry. Let me drop it so you can see it clearly. See, it's reading. Let's invert. It's reading also. MIDI reading. This reading. So this transistor is bad. You don't need to trouble yourself. Change it. I guess that is why I changed it. Then you can see that they are not new. So let's look at this. Shorted. Let's check the other direction. The same thing. Let's check the middle. Same thing. Same thing. All right. So if you look at all these transistors, you see that these 3 are bad. Now, just for you for confirmation, you can see if I test it this way now, these are the good ones. You see it. It's not reading. It should read in just one direction. So let's say the other direction. You see now reading. And no noise of short. You see it now. So if I check the middle, now reading. Let's see this reading. So you can see this one just one direction. So this is a good one. For this one, no reading. Reading the other direction. Good. Good. So this is a good one too. So let's look at the last one. Cannot even remember the value of this. Okay, this should be C7950. Okay, let's look at it. So same principle apply. You can see giving reading. Okay, that was a fluctuation. Okay, nothing in this direction. Let's change it now. Okay, reading in this direction. But this way, nothing. Let's invert it now. Let's see it now. Reading in just one direction. So this is a good one too. Let's look at the last one. No, not the last. Look at it. Reading. This way. No reading. No reading. Okay. So this is a good one. This is a good one. So let's look at my 2N3904 transistor. You can, one of the equivalent is B433, but I'm not going to equivalent today and the rest. So I'm just doing testing of all these things, and the necessary explanation you need to know as a beginner who's just getting started. All right. Once again, do well to like this video. Please do that if you know you gain value from this my video. All right. So let's look at this transistor here too. See, reading in this direction. Let's say the inverse direction. Sorry, it's too small. I see. Now reading the other way around. It's too small, right? But you just have the idea of it. So the two of them are good because they are still brand new. So intentionally just draw it out so that you see different type of transistors. Is that clear now? So thank you so much. Do well to like and subscribe to this channel. See you soon in another video. Remember, unless I forget, also I made a video a while ago. It's been close to a number of years now, yeah. And a lot of people ask questions on like, to test transistor, must I always remove it from the board and the rest? You understand? Well, let me answer to that today, since I'm discussing about transistor. Yes, it's good you remove, because when a transistor is with other matter, other components, they tend to be deceptive somehow. Although you can still get your reading from it, but to be 100% accurate, you can just decode one or two like that, then you carry out your readings on it. Okay, so for example, now this is my A1941 IC. So let's test this now. Look at this, reading in this direction. If I put it here, reading in this direction, I put it here, no reading. It's a good one. Reading here, but let's invert. No reading, no reading, no reading, no reading, but reading. So this one really still perform well. You understand? It's not deceptive, although based on the component that is the surrounding, that is what will determine how it will behave. You understand? For this one is giving me normal reading, but to be on safer side, or because sometimes you may see physical damage on a transistor and you may be reading some, it may claim it's still 100% intact, whereas it's bad. So to save yourself that stress, or let me concur to you by saying this: just decode one or two like there, then read it properly. You understand? So that you save yourself that doubt. So that's just one of the way to go about it. So I believe you know how to test your transistor very well. And this is B423 and the rest. All right. Find this video very helpful. Be sure to like and subscribe to my channel. Thank you guys. See you guys in my next video. Cheers.